distracted. So, as we learn in that great movie, Despicable Me, what is a vector? A supervillain that stole a pyramid, but it's a mathematical quantity with both direction and magnitude. Can anybody do the hip swing that he does?
Set up the show up. He's so good at it.
Do a favor for the class. Stop some time for us.
Now, you bears.
Do it.
No?
Do it and you pull. Do
It'll
it.
help us remember vectors so much better.
Yeah, I'm sure.
Alright, anyway. Let's talk real quick though some background. Scalar quantities.
They have neither.
Scalar quantities. That would be something like length, or mass of an object, or area. They're really one-dimensional. They can be described in terms of a number. Length is 5 centimeters, or mass is 10 kilograms. Area is 50 square feet. Those are called scalar quantities. They're really one-dimensional. If we're talking about velocity, it's more than just speed. Velocity is speed with a direction. It's traveling 50 miles per hour south, or 48 feet per second northeast. That's a velocity. Or a force. A force acts upon an object in a direction, right? If I, for example, you guys, listen to this. If I push a box horizontal to the ground with a certain magnitude, that's going to push the box, right? But if I push down on the box with the same magnitude, does anything happen to the box? It's the same magnitude of the force, but what changed? The direction. I was pushing in a different direction. So force has direction and magnitude, same with velocity and other things. So vector quantities have magnitude and direction, whereas scalar quantities have only magnitude.
You have to put direction and magnitude. That's how it's said.
Oh, I have to switch these, huh?
You should say.
Direction and magnitude. Oh yeah. So here's a vector. Now in geometry, initially people will say, hey, that looks just like a ray. And it kind of does, but the difference is a ray in geometry starts at a point and does not end in one direction. This is not a ray. It does not end. Or, it doesn't go on forever. It does end at point B, so it has a certain length. We only have that arrow on there to denote direction, not that it travels on indefinitely. Point A is called the initial point. These are just some vocab words. Point B is the terminal point. The name of this vector would be AB with a little vector symbol above it. The length, I think you guys know this. The length is denoted by this symbol. That's called the magnitude. Now, this vector here vector CD would be considered equal to AB. Why do you think that would be considered equal? Same distance and same direction. So vectors are considered equal if they have the same magnitude, same direction. So CD, vector CD is equal to vector AB because same magnitude
So
and direction.
they're parallel, but they're both going in like the same direction.
Yep.
So is that narrow?
Yeah, that just shows you the direction. It doesn't mean that the vector goes on forever because a vector has a magnitude or a length. Now, yeah, just quickly to wrap this up, to add vectors. Let's finish with this and we'll pick it up next time. Add vectors in space. That just means there's no graph here. They're just on a plane with no coordinate system. So add vectors in space. So let's say we had vector AB. And I want to add vector CD. I'm going to show you two different ways here. Yeah, I have time. Now, you're not able to do this probably on your, but I'm going to group that so I can move everything at once. One way to do this is to take one of the vectors so that its initial point is on the terminal point of the other vector. So as best you can, come on now, try to make that picture right there. You're going to have to redraw yours probably. So just make two pictures. Make two pictures. But make sure that when you redraw it, that both vectors have essentially the same magnitude, same direction. No. No, you can't change the direction or the magnitude of either of these vectors. You can slide a vector anywhere on the space as long as it retains its same magnitude and direction. That's what I've done here. The vector was over here, but I just slipped down here. It's retained its same direction magnitude. We good so far? Now, if you form a new vector, oh boy. That's not what I wanted. I don't know what's going on. There it is. If we form a new vector, here it is. Starting at this initial point, traveling to that terminal point. This resultant vector, that's what it's called, a resultant vector when you add two vectors. This vector that I have here in red, this is the result of vector AB plus vector CD. That's one way to do it.
So can we call it CD?
It's good if you want to. Let's finish her here.